So this is a chessboard, and this is a stereographic chessboard. Stereographic projection models straight lines radiating from a single point, like a light source, such as this LED light. When these types of light sources interact with spherical objects, they exhibit some interesting properties. If a pattern is tracked around a spherical object, like continents on a globe, a shadow cast by this object will follow a phenomenon called the inverse square law, which states that any singular point of light will spread and reduce in intensity at a rate of 1 over its distance from the source squared. So if we say the intensity of light is a value of 100 at the sphere's radius, at twice that distance from the light source, its intensity is 1/4 as strong, or an intensity of 25, but is spread over 4 times the original area. And at 3 radii, light has 1/9 the intensity, or a value of 11, but 9 times the area is covered, and so on. By manipulating the way area is distorted at distances away from a light source, you can create a uniform pattern from a distorted image around a spherical object. To display this effect, I 3D printed this stereographic projection model. But before I demonstrate, here's a quick 30-second build montage. So here's our finished model. Now, it may be difficult to tell exactly what you're looking at, but if we switch the lighting to this LED, and lower it into position, you will see a pattern emerge. This is the inverse square law in action. As you can see, the light radiating from the LED has to travel a greater distance to hit the corners of the plane than it does to hit the center. As a result, the squares near the edge of this model have to be smaller than those near the center in order to preserve a proportionate pattern. One neat thing about stereographic projections is that they preserve angles. For this reason, various types of stereographic globe projections have been used throughout history to help sailors navigate successfully over open waters, allowing them to navigate with straight lines across projections of a curved surface. As stated earlier, however, maintaining angles has its drawbacks, as the area covered by projected shapes grows as they get further from the origin. This leads to distortion, which our model exploits, reversing its effects to resolve a consistent grid pattern from the distortion.